Okay, welcome to class. So this is another biostatistics class, and this time we are considering some questions under descriptive and inferential statistics. We'll be considering some revisions, and we'll be checking the confidence interval, the mean values and the median, say for group and ungroup data. So in this case here we have a question like this. This is a real question, but we've been able to just adjust the values a little so that you will just be able to get how it is done. Okay, now we have a question like the hematocrit values in percentage for samples of mothers at a state hospital in 2014 and 2024 are as follows. So here is the table you have for 2024 values and you have for 2014 values. So the first question is calculate the mean and median hematocrit values. Hematocrit values in percentage for 2014 and 2024. Then what is standard error? Then you have what is the 95% confidence interval for the means of the 2 years. Also, you can also be asked about the distribution. That is the name of the chart that compares the distribution of these values. So we'll be considering all those in a short while. So here, when you want to solve this, you look at the values. You have to rearrange this table. You can create a column for 2014 first. Then you give the values for that as provided for us. So best way is to arrange these values. Now rearrange them in ascending or descending order. So for me, I can start by arranging them in ascending order. So I start from the smallest. So here, the smallest here is 12. So I say 12. Then followed by 13. Followed by 14. Then we have another 14. Then we have, there's no 15, so we have 16. Then we have 17. We have 18. We have 19. Then we have 20. Then we have 21. Okay, so these are the values for this. There are different methods of solving this. You can actually create a frequency table for this, where you say, okay, for example, the one that appears twice, this 14, you make the frequency, that frequency will have a value of 2. The 12 will have a frequency of 1, 13 will have a frequency of 2. You can do that. So there are different methods. So in this, in our subsequent videos, or if we have enough time, we can still cover those other methods. But here, let's start with these raw values where we just compute these raw values that are given to us. So we have them arranged this way. Now, because we are going to need we want to calculate the standard error in the long run, we will need the variance, because you will need the variance to calculate the standard error. So, and if you want to get a column for the variance, you have to calculate an S minus S bar squared. So I will tell us the meaning in a short while now. So what this means is this is for 2014. Remember we are still considering 2014. So what this means is for 2014, we are going to get the mean of 2014. So that is sigma S. So let's say this is S1. So let's call 2014 S1. So we say sigma S1. That is for 2014. So we calculate everything together. So we take calculator, we compute it as 12 plus 13 plus 14 plus 14. Remember we have 2 14. So plus 16 plus 17 plus 18 plus 19 plus 20 plus 21. So that gives us 164. So write the 164 here, that is the summation. Then remember the question says we should calculate the mean for 2014 and 2024. So the mean here, quickly we just derive that as mean is equal to sigma s over n. Now what is the meaning of this? Sigma s is the calculation, is the total of this. So that will give us sigma si, that is s1. So the mean of this value now is 164 over n, where n is the number of variables we have. So how many numbers we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So meaning n is 10. So we compute it as 10. Then let's confirm from this table, from the questions, if we are correct. So this is 10. So let's check it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means we are right here. So 164 divided by 10, that gives us 16.4. So 16.4. So 16.4, which is approximately 16. So it means when we want to get the value for the s minus s bar here, it means 12 minus the mean. 12 minus this mean we have gotten. 12 minus 16, 13 minus 16 squared, 14 minus 16 squared, 16 minus 16 squared, 17 minus 16 squared, in that order. That is what we are going to do here. So ordinarily you can also just, instead of showing it this way, because of space constraint, I can create a column first for s minus s bar, then I will now create a separate column for s minus s bar bracket squared. But because of time and space, I will just do everything together at once here. I believe you understand what I'm doing here. So okay, so let's start now. We say 12 minus 16 squared. That gives us 12 minus 16 is minus 4. So minus 4 squared will give us 16. So because the minus will be erased, minus times minus is plus, so we have it as 16. Now do the same thing. That is the format we are using. So 13 minus 16. So 13 minus 16 will give us 13 minus 16 will give us minus 3. So minus 3 squared will give us 9. So 14 minus 16 squared is equal to 14 minus 16 is 2. So minus 2. Minus 2 squared is 4. Now the next one also is 14. They have the same value, 14 minus 16 squared. This gives us the same value here because they are the same. 14 is having a frequency of 2, so that is that. So 16. The next one is 16 minus 16 squared. That is 0. 0 squared is 0. So that is 0. The next one is 17 minus 16 squared. That gives us 1. So 1 squared is still 1. So 18 minus 16 squared. That is 2. 2 squared is 4. Then the next one is 19 minus 16 squared. That is 3. That gives us 9. The next one is 20 minus 16 squared. That gives us 4. 4 squared. That gives us 16. Then 21 minus 16. That gives us 5. 5 squared is 25. So any value you are not sure, you're free to use a calculator, provided it's not a programmable calculator. In the examiners we allow that, the evaluators we also allow that. But if it's a programmable one, it will not be allowed in most cases.
Okay, so what we now do here is to get the summation of this, because we are going to need it, sigma s minus s bar squared. That gives us the total of this. So we add everything together, 16 plus 9 plus 4 in this order. So let's compute this as 16 plus 9 plus 4 plus 4 plus 0 plus 1 plus 4 plus 9 plus 16 plus 25. So this gives us 88. So we are done with this. Then we do the same thing for 2024. So 2024, let's call this now S2. So we create a column for it. Now we arrange it in the same way. Remember, we arrange this one in ascending order. So if we arrange this in ascending order, we must replicate that here also in ascending order. We can't do otherwise. If we do otherwise, when we are comparing the values, it will not tally, it will not match. So in order to avoid that, we have to do the same kind of arrangement. Here we start with the smallest also, smallest to the highest. So under the 2024 now, the smallest value here is 13. So we say 13. Now the next value is 14. Say 14. The next value is, you can dot them or use something, a pencil also to strike them also. You know you've counted those ones already. So the next one is 15. The next one is 16. Okay, 15. Let's be sure we don't have any frequency of that number. Okay, the next one is 16. But here 16 is occurring twice, so we write it twice. That's why I said we have two methods. So the second method would have been we create a frequency column for it. But this one is easier for you if you just understand this format. So, but in other subsequent videos, we can use that same method to just solve the same calculation. Okay, so let's progress now. The next one is 17, followed by 20. Then 20 has a frequency of 2. Then this one, the next value is 21. Then we now have the next value as 23. So just the way we did for 2024, we also calculate the sigma of this. So we say sigma S2, which gives us the calculation of this. We add this together, 13 plus 14 plus 15 plus 16. So we compute this together. So let's compute now. We say 13 plus 14 plus 15 plus 16 plus 16 plus 16 is occurring twice, so I'm computing 16 twice. Then 17 plus 20 plus 20. 20 also is occurring twice, so I'm computing it twice. Plus 21 plus 23. 23. That gives us 175. So this is 175. Now, what is now the mean? Remember, we are asked to calculate the mean and median for both years. So we calculate the mean first for both years. So the mean for that is for S2 now, is equal to sigma S2 over, I'm writing S2 because we denote the 2024 as S2, so sigma S2 over N. So that gives us, sigma S2 is 175 as we've calculated here, 175 over N. What is our N? N is the number of variables that is given here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So the compared here is also 10. So 10. So that means that the mean is 17.5, approximately 18. So that is the mean for the year 2024. So remember I said we are going to need this column s minus s bar square, which is the variance calculation. We are going to need this for the variance calculation. So we create a column for it this way. Now, for us to create that, we do the same thing with what we did here. This is S1, so we do the same thing here. We say S2 now minus S bar. Remember that the S bar here now is for the second mean. That is the mean of this value. The mean of 2024. So, what do? We say 13 minus the mean of that year, which is 18. So we say 13 minus 18 squared, which gives us 13 minus 18 is 5, minus 5. So minus 5 squared is 25. So we do the same thing, 14 minus 18 squared, that gives us minus 4. Minus 4 squared, that gives us 16. So 15 minus 18 squared, that gives us minus 3. Minus 3 squared is 9. So 16, the next one is 16 minus 18 squared. That gives us minus 2. Minus 2 squared is 4. So this is 16 minus 18 also. Remember, 16 is having a frequency of 2. So this gives us 2 squared as 14, as 4 also. Then 17 minus 18 squared. This gives us 1, minus 1. Minus 1 squared is still 1. So 20, the next value is 20 minus 18 squared. This gives us minus 2. Minus 2 squared. This gives us 2, so 2 squared is 4. The same thing here is 4, because we are having the same value. So 21 minus 18 squared. This gives us 21 minus 18 squared is 3. So 3 squared is 9. Now 23 minus 18 squared. This gives us 5. So 5 squared is 25. So we do the sigma, the summation, sigma S2 minus S2 bar. This gives us the summation. So we do the sum of this. So if we compute this now, we say 25 plus 16 plus 9 plus 4 plus 4 plus 1 plus 4 plus 4 plus 9 plus 25. That is 101. So that is 101. That is all we have here. So having done this now, we will now make progress. The next step will be to calculate. Remember that the question is saying we should calculate. That is the first option, is calculate the mean and median. So we've gotten the mean and median for both years. So you can summarize it for clarity purpose. You say 2014 mean is equal to, from what we got here, is 16. Then we say 2024 mean. So we are just summarizing that. That gives us, from our calculation, is 18, approximately 18. Okay, so the next step is to get the median. So we say median for group data is much easier than for group data. Remember that these are not group data. The values here are on group data. When we say group data, remember that group data are those ones that have margins. They have boundaries. Here you say, for example, you say 10 to 19. If you are given value like this, 10 to 19, 20 to 29, 30 to 39, in that order. These are group data. So these ones are not group data. So you don't need special formula for this calculation. So in our next video and subsequent videos, we will do that of group data. But here, these are group data. So the median here is to get the central values. These values are 10, each of them is 10. So for 2024, median for 2024, okay, let's start for 2014 first. 2014 is equal to the middle value. So these are 10 values, so we can't fall apart. So we say, for example, okay, we say 14, no, 12, 13, 14, 14. So these are the first four. Then we do the same thing here. 1, 2, 3, 4. These are the next four. So the middle value here is 16 and 17. So we say 16 plus 17 over 2. So that is how to get the median, because we are getting the mid value. Assuming we have 11, for example, the central value would have just been the lone value there. We say 5 apart, then the one that is middle will just be the median. But you won't be able to get the median correctly if you don't arrange in ascending or descending order. That was why I suggested in the first instance that we should arrange them in a particular order. So we choose to arrange ours in an ascending order. So that is why we are able to get the median value. So the median value here are 16. The median values are 16 and 17. So divide by 2. So we compute this. 16 plus 17. 16 plus 17 gives us 33. 3 over 2. So 33 divided by 2 is 16.5. 16.5. So this is approximately 17. So the median for 2014 is 17. So we do the same thing for 2024. So we say median for 2024 is equal to, so what are the middle values? So remember that the n here is 10, so we count the 4 apart. So we do the first 4 apart. 1, 2, 3, 4. Then 1, 2, 3, 4. So the middle values here are also 16 and 17. Invariably, our answer also is 17. So since we have mid values for this as 16 and 17, also it means the median for both years is the same thing. So you have it as 17. But if they are different, you have to still show your calculation. But since they are the same thing, you can just simply write the answer that way. Okay, so then we make progress now. What is the standard error? So to get the standard error, we must get the variance. So we calculate the variance as this. Variance is equal to S sigma S minus S bar squared over N. So N minus 1. So this is the median, the variance for this. So this is the formula for it to show it. So this is the formula we are going to use to compute for both years. Now for 2014, the median value, remember that we've done the calculation before where we have sigma S minus S1 bar, which gives it gave us 88. So we say 88 over n minus 1 is n. Remember our n is 10. So 10 minus 1 is 9. So it means 88 divided by 9. 88 divided by 9. So the variance here is 9.77, approximately 10. So that is our variance for 20. Let's call this 2014. Now we do the same variance for 2024 is equal to the same formula. So we just compute that value here now. Our sigma for sigma s minus s2 bar square is 101. So we say 101 over 9. Remember that the n for that same year is also 9. So sometimes the n may vary, so they may not have the same number of variables. So whatever the variables are, you just use that. Sometimes you can have a different year or a different group having, say, n as 10, another one having n as 15. So whatever it is, just use that value as your n. So this is 10 minus 1, which is 9. So 101 divided by 9, if we compute that in our calculator, that gives us 11.22. So that is approximately 11. Okay, we have done that now. So the next one is to calculate the standard error. So standard error, SE, is the difference in the mean. So remember we differentiated their mean as S1, S2. So this is the formula. We say square root of this, which is, the formula is Si or S1 over N1 plus S2 over N2. What is the value for S? S is the variance, so that is the first variance. S2 is the second variance. N1 is the first population, that is the number of variables for the N year, that is 2014. Then the second group, N2. So here, haven't got to the formula. This formula carries mark, half mark or a mark or thereabout. So ensure you write the formulas. So SE here now is equal to, what is our S1? S1 is the first variance, which is 10. So we say 10 square root of 10 over N1. N1 is 10 also, plus S2 is the variance for the second year, that is 2024, is 11 over N2. N2 is also 10. That gives us 10 divided by 10 is 1, plus 11 divided by 10 is 1.1. 1.1. That gives us the square root of 2.1. That gives us, from our calculator, the square root of 2.1 is equal to 1.449, approximately 2. Okay, no, approximately 1.45. Let's call this approximately 1.45. Okay, so this is the standard error we've got.